Hi friends, welcome. In this video we are going to discuss about DR-BDR concept of OSPF, why and when DR-BDR is selected. DR-BDR is selected only in broadcast and multi-access segment of OSPF. Why it was selected? Suppose you have these four routers in your broadcast segment. So if all of them have a full neighborship with each other, they keep on sending the update to each other, and it was endless. So it will congest your network. That is why in a broadcast or multi-access network, we select DR and BDR. All routers will make neighborship only with DR router or BDR router. From other router, they will create a two-way neighborship. The neighborship state was only happens till two-way. Okay, and DR and BDR are the router who will communicate the updates to DR other routers. So one router will select as DR, the designated router, other is selected as a BDR, backup designated router, and the rest other router in a segment is known as DR other router. So this is the lab which we are going to use for checking DR and BDR concept, and this is the same lab which I have used in my previous video of router ID. So before logging to lab, just have a look how router DR and BDR will be elected. So by default, the highest priority will win the DR election, and second highest will be the BDR. So default priority in Cisco is 1, and Juniper is 128, and Nokia is 1. And if all are same, then highest router ID will win the election. If highest route and if they are same, then the tiebreaker is loopback IP. If there is no loopback, the tiebreaker is the physical interface, highest physical interface IP. So that is how DR-BDR will be elected. So let's check on lab. So in lab currently I have on only two router 1 and router 6. So only two routers in the segment. So one is DR, one is BDR. So let's check who is DR and who is BDR. Show IP OSPF neighbor detail. So 10.10.1.6 is DR. It means 6 router 6 is DR and one is BDR 10.10.1.1. Why is it so? Because both have show IP OSPF neighbor. Both having the same route priority 1. So highest router ID will become the DR, which is 6.6.6 in case of in this segment. Show IP OSPF neighbor. So 6 will become the DR and R1 become the BDR. Okay, so now if I switch on the one more router, suppose R8, right? So is R8 going to be my DR because R8 is also sending the priority 1. But if I have configured the router ID 8.8.8, then the highest router ID is 8 is having the highest router ID. Suppose if I have not configured, then my 10.10.1.8 is also the highest physical IP. So they will, in that case also it should be the my DR. So answer is no, because once the router in a segment will elect it as a DR, right? They will never going to change their position until the router was restarted. Okay, the DR is always DR until unless they are alive in the network. Once they restarted, then BDR will become DR, or if BDR is also, and for BDR election happens again, and if both are rebooted, then completely new elections will be happen. Okay, let's switch on the router 8. So now my 8 is switch on. Let's check show IP OSPF neighbor. So still router 6 is my DR in this segment and router 1 is my BDR in this segment. So if we go on router 6 show IP OSPF neighbor, what you are seeing, it's having the full neighborship with DR, full neighborship with BDR and 8 DR other router. Okay. Why it's having the full neighborship with DR other router? It should be two-way, right? Show IP OSPF neighbor. Sorry, yeah, it should be a full because it's a DR, right? It's a BDR. Why? DR other router always make a full neighborship with DR and BDR. So that is why it's showing full. So it is correct. The output which we are getting is absolutely correct. So now I will restart my fourth router and check for Juniper router and check. So now my Juniper node is up. Let's check the neighborship detail here. Show OSPF neighbor. So now 6, I have a neighborship with 6 in full state. 1 is in full state and 8 with 8 is two-way state. So how neighborship is working here like this. R1, this is my R1. R1 is my BDR currently. R6 is my DR and this is my DR other. This is also my DR other, right? So DR other is having full neighborship with BDR and DR, right? Similarly, it is having a full neighborship with DR and BDR, right? But with R1, with R1, with R2, which is my Juniper router, R8 is having a two-way because all the update between R8 and R2 will be communicated by a DR. That is why we are using DRBDR. So there is no requirement of R8 DR other router to make a full neighborship and exchange a database, right? For avoiding this situation, we are using this DRBDR. R2 is sending all database to R6 and R1. Similarly, R8 is sending all data to R6 and R1, and they will forward the database to R2 and between R2 and R8. So next thing is, if I check on R8, show IP OSPF neighbor, right? That R2, which is my Juniper, is sending a default priority 128, right? But still it is not a DR. Why? Because once DR is elected, any node with a high priority, high physical interface number will be added. It will not change its position. Once it will restarted and the election will again happen, then my router 2 will become DR. So to check that, just let me restart my R1, R6 and R8 and let's check whether DR R2 will going to become a DR or not because it's having the highest priority. So now my R1, R6 and R8 is restarted. So let's check the neighborship state right now. Show IP OSPF neighbor. So now Juniper R2 is my DR, R8 is my BDR. Why? Because after selecting DR with the highest priority 128, now all three router will participate for BDR, all having the one priority one same. So what they will choose? They will choose the router with the highest router ID, which is 8.8.8.8. So 8 is my BDR. So that is how DR-BDR will work, and that is how DR-BDR will be elected. So let's do the packet capture and check some packet. Okay, so I'm doing a packet capture on R2 towards on interface G. On this interface I am doing the G0/0. In this interface I am doing the packet capture. So that is my packet capture. Okay, so let's open any packet of OSPF. First of all, check this. So currently the port, let's discuss this basic things, right? So the port, TCP port which OSPF using is 89, and the TTL value is always 1. Why 1? Because OSPF always send update to the directly connected neighbor, because it's having a TTL value 1, right? So packet will not go far from one hop. Okay, and the rest what I will like to show you here is, now my destination is 224.0.0.5. So if router is communicating with any other router, it's using a multicast address 2.0.0.5 as a destination address in OSPF. But if it is talking to the DR and BDR, it will use 224.0.0.6. So these two multicast address OSPF will use. So let's do one more packet capture. So now I have enabled the packet capture on R6 on this interface. So let's clear the OSPF on R6. Okay, OSPF process, yes. So now you can see, stop capturing. Okay, now you can see there are two destination IP address. This is 224.0.6 and this is 224.0.5. So what happening is, if it is communicating with the DRBDR, then it's using a destination multicast address 224.0.0.5, and if it is communicating to the router which is not DRBDR or DR other, it is using if it is communicating with DR other, it is using 2.224.0.0.6. So if it is communicating with router 2, it's using 5, right? Look, if it is communicating with router 2 10.1.2, it's using 5. If it is communicating with 8, it is using 5. Here you can see. Okay. If it is communicating with DR other router, means router 1, it is using 6. Okay. So guys, that is all about DR and BDR in OSPF. Thanks for watching my video, and I request you all to subscribe my channel and press bell icon so that you can get the update on time. Also, I am sharing my Telegram group link in description. You can join that also.